Hi children, good morning. Good morning to all of you. Welcome to our St. Clair School online classes children. So after a long time, we are came to in front of the online classes children. Right, due to the some technical problems and due to the some instructions of the state government and the central government. So some few days we are cancelled the online class. Right children. So again we have to start it the our online classes children, right? So whatever it may be, so first of all take care of yourself and stay home and stay safe, right children? Today we are going to discuss about one of the concept children, right? Regarding 10th class we discussed two concepts in the last classes, right children? What we discussed in last classes children? So one of the concept, that is the acids, bases and salts, and the second lesson, that is the atomic structure, right children? So I think that, I hope that, so you already listened to all the classes and you have already learned a lot of points from those classes, and the third concept comes under to our 10th class. We have one of the lesson is there, that is the periodic classification of the elements. What children? Periodic classification of the elements, right children? So before we are going to discuss about the periodic classification of the elements, so we will discuss about some few points. We have to come back to that. What we have to learn some few points in the 8th class means. See children, in 8th class we discussed one of the concepts, that is the metals and non-metals. What children? Metals and non-metals. In the metals and non-metals, what we discussed here. So in case of metals and non-metals, we have some elements are we are considered as a metals, some elements are considered as a non-metals, some of the elements are considered as a metalloids. But that is the classification not correct for the to give the complete information about the how many elements are there, what type of elements are there, what kind of elements are there. We don't have that much of information from the metals and non-metals. So whatever it may be, that is the classification not correct, right children? See here, what is the exact classification for the elements, right children? So what we know that till today we have how many elements children? So till today we have totally 118 elements children. How many elements we have children? Totally we have 118 elements we have, right children? So till now, this is the year of 2020, we have how many elements children? 118. But what about in the last hundreds of years back? We don't have this much of elements. We have very few elements. So what we have the few elements we have discussed now, right children? Right. See children, see here now we are in the 10th class, right children? Suppose if you in your class, how many students we have? Totally 55 members or 50 members are there in your class, right children? So suppose I will keep all the books in one place, so without any order, so Telugu, English, Hindi, Maths, Physics, Physical Science, Biology, Social Studies, and your notebooks, all textbooks I will keep in a one of the edge, right children? So one of the heap I will arrange like that, right children? So I will arrange all books in a heap. Suppose I will ask you, please give your 10th class textbook means how you will give to me. So it will take some time. You will search first where is your textbook, and you have to first you need to find out your textbook. Then after some time you will give your textbook, right children? Otherwise, those same textbooks we have to arrange in a particular order. So in all Telugu textbooks in one particular order, and after that all the English textbooks in one particular place, in all Hindi textbooks, all maths textbooks, all science textbooks, all social textbooks. Suppose if you keep it in order according to your roll number wise, then suppose I will ask to you, then you should give easily, because of we are arranged in a particular order. That's why see here, when you are arranged in a particular order means we can easily find out to your book, then you can usually you have to give to me, right children? So similarly, suppose if you went to any supermarket, right children? So if you went to any supermarket means just you have to pick up your what we have the source, what you want the source, what you want the paste, what you want the different grocery items you have to collect from the supermarket, right children? So because of they will already arrange in a systematic order, they are already arranged in a systematic order. Then similarly, suppose if you are going to the medical shop, right children? So suppose if you are in that place, suppose anybody is asking, so I want some paracetamol tablet, I want for some of the cyclophoenic tablet. If they will ask like that, means if you will give easily, no, it is difficult to give the tablets to them. But if you are asking to the medical shop, who is the boy is there, suppose if you want to ask to them, they will give easily because of they know where they kept the tablets in the systematic order, right children? So whatever it may be, if we can consider anything, we need to arrange in a systematic order. We need to arrange in a systematic order. Similarly, here also we have how many elements, children? 118 elements. So suppose if you have 118 elements, means if we can arrange in order, we cannot study about those elements. Suppose if you want to study about those all elements, means we need to arrange in a particular order, right children? So for that only, most of the scientists, they are proposing their classifications, right children? So they are proposing their classifications for the elements, right children? See here, in that process, first of all, in the year of 1661, one of the scientists, Robert Boyle. Who is the scientist, children? Robert Boyle. He gave one of the definition for the element. So the definition of element was given by Robert Boyle. Who is the scientist, children? Robert Boyle. Who is the scientist who was given the definition of the element, children? Robert Boyle. Right children? What he was given the statement about element. Right? So he gave the definition of element. Element is the basic form of matter. Element is the basic form of matter which cannot be broken down into simpler substances by either physical reactions or chemical reactions. Element is the basic form of matter which cannot further divided into simpler substances by making either physical reactions or chemical reactions. That is the statement was given by Robert Boyle in the year of 1661. At the time of 1661, we have only 13 elements. How many elements we have, children? Only we have 13 elements. Only we have. Okay. So if we have only 13 elements, means we can easily say that what are the process of what is the properties of those elements. We can say easily. But coming to at the end of 18th century, here when we came to the 18th century, at the time of Antoine Lavoisier, they have found more than 11 elements. Moreover, 11 elements. That means at the 18th century, total how many elements we have, children? So totally 13 plus 11, we have totally 24 elements. How many elements we have, children? Totally 24 elements we have. Okay, children? Right. The year of 1865. In the year of 1865, we have totally 63 elements. How many elements we have, children? Total we have 63 elements. Right, children? So at this time, this is considered as at the time of Darwin scientist. Right, children? Then here at the time of 19th century, or 1940, the time of 1940, here we have similarly. Here 91 elements are obtained from nature. 91 elements are obtained from nature, and 17 elements are synthetic elements. 17 elements are synthetic elements. Totally, at the year of 1940, we have total how many elements we have, children? Totally 108 elements. Total how many elements we have, children? 108 elements. Right, children? So now coming to the century of 2020. At the time of 2020, that means at the time of 2020 or nowadays we have more than 115, more than 115 elements we have, children, right? See here, suppose we have 13 elements, means we can easily say that what are the properties of those elements, which is easy to us. Suppose we have only 24 elements, okay, somewhat what we have to manage. Suppose if we have 63 elements, it's somewhat difficult. If it is 108 elements, it's too difficult. Now we have totally more than 115 means till now today we have how many elements, children? Totally 118 elements we have. So to study about those all elements, it is too difficult to us, right, children? Suppose if you want to study about these all elements, means we need to arrange it in a systematic order, right, children? So we have to arrange a systematic order, means what we call here. Suppose in our weeks, in a week how many days we have, children? Totally 7 days we have. Sunday, Monday, Tuesday, Wednesday. So like that, Sunday again it will came after 7 days. Okay, so Monday again 7 days. Like that, here that is the one of the systematic order. Sunday, Monday, Tuesday. Like that, it is the systematic order. It will be coming after 7 days. So that is we consider as a periodical changes, right, children? What we have to consider here? Periodical changes. The periodical changes means time dependent changes. What, children? Time dependent changes. Like our seasons also considered as periodical changes, right, children? So morning, evening, sunset, sunrise, these are all considered as a periodical changes. See here, based on one particular time it will be changes. Same like that here also, our elements, what we have 118 elements can be exhibit the different properties. So those different properties we have to study about those properties, means it will be arranged in a systematic order in a periodic manner. That's why this is the classification we consider as a periodic classification. What, children? Periodic classification. About what? About elements. That's why we have to consider as the name of the concept is periodic classification of the elements. What, children? Periodic classification. Periodic classification of the elements. Periodic classification of the elements. So today we are going to discuss about one of the concepts, that is the periodic classification of the elements. Right, children? So here about periodic classification of the elements, suppose if you want to study about these periodic classification of the elements, means initially one of the scientists, who is the scientist, means one of the scientists, that is the scientist, he was considered that only hydrogen is the building particle of the periodic classification, he said. But here hydrogen atomic number is 1. Still today we are considering the atomic number of hydrogen is 1. Because of everyone we have to consider the atomic number of hydrogen is 1. Right, children? But here, suppose if you want to study about these all elements, means so one scientist, they are given one classification. In that process, first of all we need to discuss about one of the classification, that is the Dabarnese classification. What, children? Dabarnese classification. Right, children? So here Dabarnese, he is the one of the German chemist. Right? So at the time of Dabarnese, we have how many elements we have, means totally 63 elements we have, children. How many elements? 63 elements we have. So Dabarnese, he was considered the one of the property based on the atomic weight property. What, children? Based on the atomic weight property, he was classified the elements in a systematic order. That is the classification we consider as a Dabarnese classification of the elements. Dabarnese classification of the elements. So he was proposed that we are considered as a Dabarnese. He was taken as 3 elements as a group. 3 elements as a group based on the increasing order of their atomic weights. Based on the increasing order of their atomic weights. Okay, children. See here, first we discuss about one of the classification, that is the Dabarnese Prio's law. What children? Prio's law. See here, first of all, Prio's law. See children, he was proposed in the 3 elements LC group. 3 elements LC group based on the increasing order of atomic weights. Based on the increasing order of atomic weights. Because at that time we know that is the increase. We know only atomic weights. Right children, based on increasing order of atomic weights, he was considered the 3 elements as a group. Right children, he gave the one of the statement. What is the statement means? Here the atomic weight of middle element, the atomic weight of middle element, or the atomic weight of second element, the atomic weight of second element is equals to average of first and third element. Actually, see here, suppose if we can consider the 3 elements as a group, A, B, C means here the atomic weight of middle element or the atomic weight of second element is equals to average of first and third element. Average of first and third element. That is the statement was given by Dabernev. Who is the scientist children? Dabernev. Right children? So based on his statement, we will give some examples. Right children? So in our textbook also, we have one of the tabular form is there. So please also look at the tabular form. Right children? So what we have the examples means, see children, based on the average of the atomic weight of second element is equals to first and third element. So based on that, we have, suppose if we can take lithium and sodium and potassium. It is the one of the example for Dabernev Prio's. Tri means 3, R means elements. Right children? So lithium, sodium, potassium. Suppose if we can consider these 3 elements, the atomic mass of lithium is 7. The atomic mass of lithium is 7. What you know that the atomic mass of potassium is 39. So here, when we take in the average, means lithium plus potassium by 2. Lithium plus potassium by 2. So then what we getting children? 7 plus 39 by 2. 39 plus 7, 46. So 46 by 2 means how much will get children? 23. So 23 is the atomic weight of sodium. 23 is the atomic weight of sodium. Right children? See here, the average of first and third element is equals to second element. Right children? And suppose if we can take one more example. Here suppose if we can take chlorine, bromine and iodine. That means here the atomic mass of chlorine is 35.25. Atomic weight of chlorine is 35.5. And here the atomic weight of iodine is 127.6. Right children? Here we are taking the average of these 2 elements. We have to consider the chlorine plus iodine by 2. That means 35.5 plus 127.06 by 2. Right children? Approximately how much we are getting children? So 127.6 plus 35.5. See here 11, 12, 13, 6. So that means by 2 means weights are 16 and here 2 1 are 2, 2 5s are 10. Approximately how much we are getting, children? 81.5. 81.5. But here the atomic mass of bromine is 80, children. How much we are having? Atomic weight of bromine is 80. But how much we are getting here? 81.5. 81.5. Similarly, we have some more examples like sulfur, selenium, tellurium. And fourth example, calcium, strontium, barium. Right, children? So, and some more example like here chromium, manganese, and iron. So these are all examples of Daburnir ions. Right, children? And tried these two examples. You should try these three examples at your home. Right, children? So suppose if we can observe these all examples, so what he was given the statement, children, the atomic weights of first and third element is equals to second element. He gave the statement, but the statement was applicable for only some elements. Right, children? So Daburnir classification does not give a complete information about classification of the elements. So Daburnir triads also we have some limitations we have, right, children? So what are the limitations of Daburnir triads law? What are the limitations of Daburnir triads law? So what are the limitations of Daburnir triads law means at that time what we have the elements. Daburnir does not explaining about those all elements. Daburnir does not explaining about those all elements. So here the first limitation, what is the first limitation of the Daburnir triads means here he does not explaining about all the elements. He does not explain about all the elements. What we have the elements at the time of Daburnir, those all does not explain by Daburnir classification. Right, children? And the second one, here Daburnir classification is failed to explaining about low atomic weights and high atomic weights. Low atomic weights and high atomic weights. Like low atomic weights and high atomic weights like chlorine, bromine, and iodine. So here chlorine having 35.5, iodine have 127.6. Right, children? So that's why here, so for higher atomic weights elements, for lower atomic weights elements also it does not explain. Right, children? And here third one, here what have the properties, based on those properties, based on increasing order of atomic weights, he does not arrange as a based on increasing order of atomic weights. Right, children? So these are the some limitations of the Daburnir classification of elements. But whatever it may be, Daburnir, what he was proposing the classification, it gave the one of the clue about to introducing the one of the systematic order for the elements. That's why, children, here this is the Daburnir classification does not give the complete information. So it was explained. Some more drawbacks are there in the Daburnir triads law. Right, children? So we have to consider the one more classification. Right, children? So one classification not enough means we need to go for another classification. Right, children? So we have some more classifications we have. After that, after completion of Daburnir triads law, we have one of the classification is there, that is the Newland's classification of the elements, then Mendel's classification of the elements. Right, children? So these are the classifications we will discuss later. Right, children? So what I discussed all the points, please all of you note down in your notebook, and you have to maintain the CW and you have to maintain the homework, that means HW answer. Right, children? HW magazine should write the 5 questions per day. Right, children? Okay, we will meet tomorrow. Thank you. Bye. Good night.